So we're going to talk about false position method. So last time we discussed about the bisection method. So these methods belongs to the bracketing method of the root finding method of numerical methods. So false position method is partly sa bracketing method. So if you say bracketing method, so dapat the root itself, it should be, ang atong estimate should be bracketed by two estimated values, which is let's name this one XL, and other estimate is the XU. So like the bisection method, we have two estimate values that brackets the real root, so XU and XL. So if this is XL, so the Y value niya, which is f of XL, so anong Y value sa XU is this one. So this is f of XU. So if you connect these two dots, so there will be an intersection between the x-axis and this line, So this line, the intersection between this line and the x-axis, this is our estimate root. So let's call this one XR. So muna itong estimate root. So if we'll use the false position method, so false position method, so makuha na to ang value sa XR. So if you have na our new value of XR, next so this will be our new XL. So pagkahumana na, so if this is our new XL, draw na po kag line ra, so this will be our new XR hantod na we're gonna find the real root. So after some iterations, we're gonna find the exact root of the function using this algorithm. So how do you find the formula of false position method? So as you can see, if you use similar triangles, so this is f of XL. So if you use similar triangles, where XU, so muna ito ang, so this is the bigger triangle, this is the smaller triangle, where XU minus XR. So this is our XR. Oh, wait. So where f of XU, so this is f of XU, this one, f of XU, divided by, so the bigger triangle divided by over this one, kaning gamay, which is f of XU minus f of XL. So this is f of XL, muna itong f of XU. So if ato na siyang i-minus, so f of XU minus f of XL. I-plus na ito so f of XU plus f of XL. So since this is naman siya sa negative, so that's why negative siya, which is equal to kani, and then the kaninga side, the base of the triangle is equal to, so this is XU minus, so this is the bigger, the smaller one, which is XU minus XR, divided by the bigger one, which is equal to XU minus XL. So the only value that is unknown in this formula is the XR. Kani XU, XL, these are all approximate values, So if you have XU and XL, we can find the value Y value of x sub u and x sub l. So the only unknown variable here is the xr. So since the approximate or the approximate value of our root is equal to xr, so we're gonna find xr, which is ato ni i-cross multiply, no, balhin nato ni spekas. So meaning xu minus xr is equal to xu minus xl times f of xu divided by f of xu minus f of xl. So since mag-negative man ato na lang ibalhin diri, no? So therefore xr is equal to, balhin nato ni diri kan xu balhin dira. So therefore times mo so where xr is equal to xu minus f of xu times xu minus xl divided by f of xu minus f of xl. Or as you can see, pwede po natin ni change ang sign. So if it is, so how about if we take out the negative sign, xu minus, paano natin negative, so negative f of xu, so mahimo ni siyang xl minus xu. Divided by negative f of xl minus f of xu. So cancel na. So therefore the first position method formula is equal to this one. So f of xu times xl minus xu divided by f of xl minus, so this is the first position formula, no, where our estimate of the root is equal to xr. So like the bisection method, we are going to have the algorithm, no? So first choose xl and x of u, so that's the same with the bisection method, no, and the value of y sa xl and xu, it should be less than 0 in order to find the root. So the estimate root is equal to find the estimate of the root, you will use the formula, and then check nato if f of x sub l times f of x sub r is less than 0. So meaning is less than 0 ganin duha, meaning there's a root in between these two values, meaning x sub l is equal to x sub l, then atong x sub u mahimo na siyang equal to x sub r. So this is the same with the bisection method, no. So kung ano tong formula, then kung ano to ang absolute error, relative error. So if atong relative error does not meet the requirements, which is dapat the relative error should be less than or equal to the pre-specified tolerance. So if yung relative error is greater than sa pre-specified tolerance, go back po ka sa algorithm, which is the step 2, no? Step 2. But if your relative error is less than or equal to pre-specified tolerance, so that's your final answer. Muna mo ang real root. So let's have an example. Okay, so this is our example. So we are using the same equation na pareha sa bisection method, where atong xl is equal to 1, xu is equal to 4, and we are going to conduct 3 iterations lang regardless of the relative error nga itong makuha, no? And then we're going to use 3 decimal points, 3 decimal, no? So iteration 1, so iteration 1, so in our step one is check doon nato, no, if whether it is less than 0 or not, itong f of xl. I think ihatag naman ni siyang estimate, so it should be na I wrote in between xl and xu. So dito na ta sa x sub r. To sa ibutang ang givens, no, xl is equal to 1, xu is equal to 4. Ato equation is x cubed minus 20, which is equal to f of x. So we're going to find x sub r, which is equal to, formula galeta niya is x sub u minus f of x sub u times x sub l minus x sub u divided by f of x sub l minus f of x sub u. So what is our x sub u? 4 minus, this is f of 4 times 1 minus 4 divided by f of 1 minus f of 4. So therefore 4 is minus, so since x cubed minus 20, so 4 cubed minus 20 times 1 minus 4 divided by 1 cubed minus 20 minus 4 cubed minus 20. So use your calculator. So xr dayon na to is equal to 1.905. 1.905. So naana ta sa step 2. So in step 2, i-check na to whether what will be our new xl or our xu. So to check, we're gonna use step 2. So f of x sub r times f of x sub l is equal to f of 1.5 times f of 1, no? So ano po nato mga value is negative 13.087, negative 19, no? So since negative of negative, so it's greater than 0. So unsa to greater than 0? So if it is greater than 0, ang xl na to is equal to xr, no? So meaning sabot ani, if you have here muna tong xr, muna to ang xl. So if it is greater than 0, so wala tayo root na nakuha dira, no? No root in between. So if it is bali xl ni kani xr, no? Wala tayo root nakuha. So if wala root diri, so therefore possibly ang root na to is na on the other side, xr in between xr and xu. Since this is greater than 0, so therefore atong new xl ani is equal to xr, no? Dali ay xl equals to xr, then xu is equal to xu. So therefore xu is equal to xu. So therefore xl is equal to 1.905, xu is equal to 4, no? So since napapunta sa iteration 1, so isip ta na to kuhaon ang relative error. So dito to sa iteration 2 where xl is equal to 1.905, xu is equal to 4. So xr is equal to 4 dito ni times f of 4 times 1.905 minus 4 divided by f of 1.905 minus f of 4. So this is 4 minus, so this is 4 cubed minus 20. It's 1.905 minus 4 divided by 1.905 cubed minus 20 minus 4 cubed minus 20. So use your calculator. So kuha na to is this is 2.385, no? 2.385. So kuha na to ang relative error, absolute value, no? 2.385 minus 1.905, 2.385 times 100. So atong relative error is 20.126%. 1.2. Okay, let's check, no? Ang by root in between. So step 2, f of x sub r times f of x sub l. So this is f of 2.385 times f of 1.905. So ang value na nakuha na to is negative 6.433 and 0.087. So ang result na to is greater than 0. So therefore, if greater than 0 na siya, ang XL na to is 2.385 and XU na to is equal to 4. Na to ang new value. So papel. So let's continue rin, no? So we're going to muna itong new value, no? So therefore let's go to iteration 3. Iteration 3 where ang XL nato is equal to 2.385, XU nato is equal to 4. So ang XR nato is equal to 4 minus diretso na 4 cube minus 20 times 2.385 minus 4 divided by 2.385 cube minus 20 minus 4 cube minus 20. So ato nakuha nga value is equal to 2.591, no? 2.591. So relative error na to is 2.591 minus 2.385. 2.591 times 100%. So therefore relative error is 7.950%. So since 3 conduct 3 iterations lang ta, so therefore atong root na to is equal to 2.591, no? So if you plot this one using the iteration table, no? So sa first iteration, no, 1 XL log XU, 1 man na to ang nakuha, no? You have 1.905, and then as you can see atong nakuha ang relative error at second iteration is 20, then yung drop siya to 7.95. So i-compare na to siya sa bisection method. So this is the bisection method. Wala man. Bisection. So compare natin sa bisection method. So at first iteration, second iteration nakakuha tag 23%, and the last iteration which is 20%. So if you compare this method to the bisection method, sa bisection method 23 man rin, no? Dayon, as you can see, sa false position method 20%. So meaning the false position method converges faster compared to bisection method. So if you say converges, meaning faster siya mo find sa root, no? Real root. Mas paspas siya mo find sa yung real root. So that's the difference between the bisection and the false position method.